G'day, Michael here. If you ever have to install latches like these, which is a common type of latch, they're pretty consistent regardless of the brand. 2¼ inches, yeah, they use inches, by 1 inch is the plate size. This is a common striker plate design. Whether you have radius corners like these or square corners, there's no consequence with this latch template system. So here you see that, one of the templates. This is the actual passage latch, which is the latch part that goes in the door, with the clamp assembly all put together. Now these are 12mm metric thread. They're on stainless steel, and they're a cut thread, so they're quite precise in the way they're made. That's actually why I selected them. You can see here a smooth part of the shank of this threaded rod. Now I've cut that into the threaded rod so as to be able to use like a cordless drill to wind the thread in and out. And that saves you quite a lot of tedium when you're trying to set the templates up. What is new in this design is this dust extraction port. And that fits the common European 34mm vacuum cleaners like the Festool or the Metabo. Here you can see many different kinds of template guide. Now the common shank sizes for routers here in Australia are based on inches still. A collet which gives you either 6mm or 1/4 inch or 8mm. 8mm and 5/16 are very similar measurements, so often one will do for the other. But these happen to be a 1/4 inch shank, these cutters, but they are a metric cutter size. And I suspect wherever you are in the world you'll be able to get a combination of whatever shank size you need and whatever cutter size you need. For argument's sake, this is 10mm. So if you wanted to tweak that a little bit and there's no like 9.5mm, you could go for 3/8, which is near enough 9.5mm. So you get pretty high incrementation with the cutter resolution by switching between metric and imperial. As you can see with all these number of template guides, they are all for different routers, with the exception of these three. They are for one router. So some routers you can buy multiple different sizes of template guide, others you're basically given the one you've got, and some don't even come with template guides. So when you're selecting a router to buy, you'd have to have one that has a template guide. There are two main designs of routers, this fixed style and the plunging style. Both these router designs have their advantages. Fixed design, but basically one way or another you end up with some kind of pretty primitive base really, which basically clamps onto the motor body, and you have the template guide installed in the base. Is that visible? Yep. So you have the template guide installed in the base. And there are 101 different ways they do that, surprisingly. But they're kind of the simplest. This one's even got the ability to tilt, but that's irrelevant for this point. In any case, you need this kind of device, a template guide. Now, what is the only thing you've really got to worry about is the difference between the outside diameter of this template guide and the cutter determines that offset. Now, the templates that I've designed are designed for a fairly tolerable range of between like 3mm and 1/8 of an inch. Now, of course, the template guide occurs both sides of the cutter, so really the difference between the cutter and the template guide is anywhere from about 6mm to about 6.5mm, well actually 1/4 inch. If you have a difference of 1/4 inch, the cutout will be fairly tight. If you have a difference of the 6mm or a 3mm offset, you'll have clearance. If you're doing these cuts before you paint the doors or jambs, you may want that clearance just to clear the paint, so it works in your favour. The other thing I found was quite interesting is even if you have a larger clearance, by having the clearance being like consistent around the product, it still looks neat and tidy. So don't be too concerned if you've got a 0.5mm gap. That seems to work quite well, so long as you place the latch in situ so that there's an even margin around. So it's really determined when you screw the part in. So the other style of router is a plunge router. They are usually more highly developed. This router here is about 50 years old. Now this guy, like I said, is a 50-year-old router, near enough. I was a small child when my father bought this one. And already you can see some advanced features in the fact that it can plunge up and down. Yes, that's a feature. You can vary the depth stop by winding this up and down. You've also got two stopper settings. So you can choose between two different settings. You adjust the difference and you adjust that as basically your primary stop and this is a secondary stop. Okay, so that allows you to set the router up for two different depths. Now that can work in your favor for this particular job. And I've got a talent in the template which uses the ability to have two different depths. A big advantage of this type of design is you can have the template guide resting in the template without having the cutter exposed. There's a much reduced risk of you hitting the template with a spinning cutter. You can see here whether we have the rounded corners or the square corners. There's no real consequence to the template design. The only thing that's necessary when you have the rounded corners here, you do need, in the case of the Schlager, you need to have like a 1/2 inch cutter. So your template guide has to be fairly large. if you use a small router cutter in conjunction with a small template guide, it will produce a much smaller corner. This is the cutter template combination I used to produce this cutout. Because I needed the 1/2 inch cutter, I needed a large template. So using a small template like this in conjunction with an even smaller cutter will not produce these radius corners. You need to use a larger cutter. That's the only real change you have to make if you do want to do rounded corners. Using a template guide cutter combination like this will produce tighter corners, and that's much better for doing the square cutout. So depending on what you need to do, you may choose to have a smaller cutter with a smaller template guide if you want to do square cutouts. The trade-off with using a smaller cutter and a smaller template guide is you have to make many more passes, and it's more tricky to get everything right. If you use a larger cutter, there are fewer sweeps you have to make of the actual cut, but of course you need a bigger area to cut out. So there are advantages to smaller and larger cutters. It's a matter of your choices. In essence, this is the template, and it can be held in place either with screws, which is the easiest way, or you can use the clamp assembly. Probably the easiest way of measuring the cutter offset is if you've got a set of calipers. Close it on the cutter, there we go. And wind the cutter around so it pushes the caliper open. That's 10 millimeters. Okay. Press the 0 on your caliper if you've got a digital set. Test it against the template guide. So that's 6.8, 6.9. So that means I'm probably a millimeter too big. We're after a difference of 6 millimeters all the way till about 6.4 millimeters, or 1/4 of an inch. That's the intended design clearance. You can of course exceed that, but that's up to you. So between 3 millimeters and 1/8 of an inch is the designed offset, or comparing the cutter to the template guide, that's 1/4 of an inch down to 6 millimeters. So that's the intended, or the designed difference that I've allowed for, because you can achieve that with both metric and imperial, and the variation is only 0.3 of a millimeter odd. So back to the actual template system. Now it looks pretty complicated, all these bits and bobs, so let me break it down. This is the actual template for a latch. You can see that's obviously a title business. No, that's obviously the LTS 205 system. It's for a passage latch as opposed to a cavity slider. And this is actually latch number 1. So this numbering system allows me to have multiple different, types of latches. But so far, I'm just doing this one type for a passage. Now let's have a look at other details. We have a center line here, so you can work from a center line. There's also 2 holes here. That's intended for driving screws into place. Looking at the back side, you can see there's these sort of gullies here. They're basically to allow for the clamp blocks to slide together, minimizing the height of this template. And these holes here being threaded to hold the threaded rod. As you can see, this is the assembled set, so the threaded rod. This is actually, the threaded rod is actually fixed in place according to how you drive it in. So you can actually wind the threaded rod through. Now I'm turning the rod, not the nut. The nut happens to be just on it. So we can change the centering of the whole jig by that. And then you have the nuts that act upon the clamping blocks. Now looking at the clamping blocks, I've got these embedded O-rings which provide like traction, so that you actually don't need much force to tighten the clamps together. In fact, it's designed that way so that if you're working on pre-finished materials, you're not going to damage the product by having lots of pressure marks from clamps, etc. So it is deliberately designed so you don't put much pressure on these clamps. It's not required. Okay, the other thing you may notice, there's this dust extraction port. That's for the common, Festool or Metabo vacuum cleaners, 34mm taper, and the Helmreich branding, so you can find me again if you need to contact me for details. So, all right, I think that's about that described. This dust extraction has proven to be extremely effective. I was quite surprised actually how well it works. Even with the clamp in place, using a spade bit to drill out for the latch, the actual the body of the latch, all the debris is extracted away. So it was quite effective. That extraction is a new feature on this version versus the previous version. These nuts, I've actually created a thread that is not a standard cut thread, because the standard cut thread, it was still binding a little bit, so you couldn't freely spin the nut like you can this. This is actually a thread that I've created slightly out of standard so that it works really well with this clamping assembly. And you only need like a 2-finger tighten. You don't need a lot of tension to hold this in place. So you won't mark your product, and it still provides excellent traction with these O-rings as providing that traction, so that the template does not slip around. This little guide block looks kind of complicated and also kind of simple, but there's quite a few hidden things in this. Obviously the center point of the body of the latch would be, where you bore the hole for the body of the latch is centered on that center point, right? This back area here matches the size of the latch plate. So you can see that it occupies the same space as what the latch plate is. It's the same length and same width as the latch. So if you've got a line or a cut or something that is actually this cutout already, you can refer to that to locate this. Right? So you can use that to find the center point or the location of where the actual template has to be placed compared to that latch marking, whatever it is. So you can use this to work backwards and forwards either way. You can use it if you've got the template clamped in place. You can then put this into the template. So let's say you have this template clamped on the door. You can put this into the template and it'll give you the center point of the latch. And you can use a drill to spike the hole. If you have the center point marked on, say, the door where the latch has to go, you can turn a screw into that, fixing it to the door, and then bring this clamp to that location using this guide block to then adjust where this template is placed. So you can use it either way. If you choose to do like the jam first, it doesn't matter. You can work to a line from that jam to the door and use this guide block to that center line. Or if you choose to do the door first, then you can transfer using the other guide block, which corresponds to the striker plate, to then place the striker plate template. So these two blocks are actually, they might not look like much, but they are quite an integral part of how the template system works. It lets you find one location from the other. So these are not something to lose. These are very important. This is really the last component of the latch template system. It's a simple insert that goes into the striker template. Now you can see this is for the striker of the latch type 1 or striker 1. If we have this on the jam, I'll show this in a minute, but if you have this on the jam, you can use this template. If you're using a plunge router with a second depth setting, you can plunge to a greater depth and this will cut out the hole for the actual latch socket, like where the latch pin goes into on the striker. With all the routers, I find with template guides the dust extraction does not work very well, and that's why I've designed in the dust extraction into the clamp here. As you can see, the dust extraction occurs in this space here, and that is in the case of a jam, there's a clearance of whatever your doorstop is in thickness. Okay, so you can see with the second clamp block out of the road that when this is resting on a door, which is at this height, there's ample opportunity in this space for the swarf to be sucked out from where the cut happens. Hope that's clear enough. Does that make sense? So if you imagine this working on the edge of a door, you can see there's ample opportunity for the dust extraction to work. Okay, at its heart, this template can be used in a very simple format. If the door is something in the order of like 1.25 inches thick or 34 millimeters thick, you can simply butt this edge against your doorstop. Now this is a mock-up, I'll just take that out. Just a mock-up of a jam section with a doorstop included, the doorstop and the rebate for the door. So if I just, unfortunately this is not a wall, I have to just put in the vise to hold it, so it's a bit of a, it's a theoretical thing. Okay, now the back edge of these blocks is in line with the running surface of that template. So jamming the blocks hard against the doorstop makes this surface flush to that surface. So that's the furthest back the template can go, right? So that will produce a 3mm or 1/8 of an inch inset according to your cutter offset for this plate. So even with this hard on, the striker plate would actually end up about 3mm clear. very rarely will the door be that thin, and you certainly don't necessarily have to place it hard against the doorstop. So this rebate for the door would be pretty much proportional to your door thickness. This rebate could take something like a 45mm door, which is about 1 3/4 in the old currency. Very handy, this rule's got both. So the simplest way to get the strike in position is to get a center line for where the latch would work. Place this on that center line. You could even use the alignment block on that spot, and then that would give you your position. So if you were to screw this in center, if you were to turn a screw in here at the center line of where the strike has to go, like let's just say we'll set this up. Okay, so let's say your door is 38mm thick. You might set the center line to 20mm, so as to have 19 either side, let's say, of that center line, plus a 1mm clearance, or whatever the imperial equivalent is for that. 38mm is 1.5 inches in the old currency, so work to whatever clearances you like. But basically, let's say that's your center point, which is the design center point of where the latch pin would be, which corresponds to dead center of the latch. So straight down the center, both ways. Okay, so you'd screw this on in place. So that then can be used as a guide for the template, which you then could screw on. Actually, I'll do that in this case. Make sure that's parallel. Now it's important with these screws, the brassy looking one that I'm rotating there has got like spurs on it, and the one in this hand has got the smooth countersink. So what you need to do is use this type of screw, not something that's self-countersinking. So that's out, because that will damage the template, whereas this will actually pull tight. Okay, so there you can see the net result. Now, using the 2 screws to hold the template into the jamb obviously is a quick way of applying it, but the trade-off is you don't have dust extraction, and as we take this off there'll be 2 screw holes where this was. But if you have to obviously finish this material first and you want to cut the latch in later, then you need to use the clamp assembly. This is definitely a quicker, easier way to set up. Alright, so how do we set up the router? So we need to set the depth stop to get this thing so it's zeroed and it's workable. We can put the router in the template, release the, you can see it, release it, set the depth to touching the surface. Okay, so that's that. It's touching the surface. So now that is, the thickness of the template through to the surface of the jamb. So I set this clearance here on the stopper for the thickness of the strike. That's it there. Okay, so if we wanted to go a little bit deeper, we'd wind it back so there's more of a gap here. If we wanted a bit shallower, we could do the opposite. So this clearance here determines our, our primary cut to let the striker in, and this is the extra depth for where we're going to cut the socket for the latch pin. All right, let's put that back for the strike setting. Make sure you reset to the smaller setting before you start cutting your striker in. Another side effect of not having the clamp block here is we have no dust extraction. So this is a messier, dustier way. Now we can put this insert in. This particular cutout doesn't have to be super precise. And this is where we employ that second depth setting. So I'll switch that around. Right, so that's my depth stop now. Just going to do that so you can see it. So that's what we have now. Okay, so let's see how that fits. So that's that. Now you can see there's, take my finger off, you can see there's a little bit of clearance around the outside. So that's ample if you've got to paint later, Also, if you made the offset between the cutter and the template guide, that 1/8 of an inch, that will be greatly reduced. Still have enough clearance to put the part in, but the gap will be reduced. So this is quite well set up for doing this process before painting. But of course these two holes need to be cleaned up and stopped. And that operates, you know, it's basically that striker plate's perfectly let in, ready to be screwed on. Here we have a mock-up of the door. Now, I did the striker according to the centre line of this door. This is like 38mm thick, or 1.5 inches in the old currency. I've set the latch centre point in the jamb at 20mm from the doorstop. Obviously the centre of the door is 19mm, and the height of the door was, the latch was set at 120. Now you might have to take off your clearance, etc., whatever it is you've got to do. But anyhow, that's normally the centre line I'm going to choose. If I was going to use this guide block to centre that, I could. Or if I was going to just set up the clamps so they centre on here, and then use that to run all the doors, and then go and cut the jambs later, I could do that too. So it depends which way you want to go. But let's assume we've had the jamb cut in place first, and we need to make the latch here line up with what we've got on the jamb. Okay, so that's the process I'll take. I've started that with the drill. Alright, so we've got this placed according to the centre line. Again, if we had to use the height as a guide, we've got the this body here represents the 2 1/4 inches of the latch, so it's the same sort of width, well in this case height, and then the width also matches the other way. So this plate here, this flat bit on the bottom, is an equivalence to that. Alright, so drop our template on, and then basically using that as our guide for these clamps, we'll just spin up the clearance for the clamps. Make sure it's parallel. And an easy place to see parallel is compare this dimension to that dimension on both sides, and you can see if there's any, like a twist on your template placement. Now you can see I'm not putting a lot of force on these nuts. They don't have to be terribly tight, and they will not creep around. You can see I'm moving the bench around by this. Alright, so let's take that guide out. Get our extraction handy. Now again, if we were to set the depth, we need to drop this down until the cutter hits the door. Lock that. And here we have to set that clearance by winding that up until this clears. That's basically our clearance. So there's our depth stop set. See, that result is all nice and clean. So the dust extraction has worked beautifully to keep that dust at bay. As you can see, the dust extraction has worked beautifully, even using the spade bit, and it works fine if you're working vertically as well as horizontally. Alright, so I'll take that off. If you want to reuse a setting, obviously you'd want to leave one side of the knobs set at whatever, and just loosen the second side. So maybe you remember one side or the other as your reference, so you can find it back to the same setting later. I'll just disconnect the extraction, so I'll take that away. You can see how clean that hole has been left. Rounded corners should just fit that fairly well. And there we go, that's set in. And again, this has got the clearance for the paint, so if it's centered, it looks quite neat. Okay, take that out. If we need to let in, for something square, just simply need to chisel out those corners. Let's pop the latch in. Well, that ended suddenly. Well, I guess that's it for this video. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.